Hey everybody, it's Mr. Chris at the Hudson Area Public Library. As always, please like and subscribe to our YouTube channel so we know you're getting these videos and you'll see the ones coming up. So we got a nice day today. We're running out of the nice days coming into the winter here, so I thought I'd try to fit in one more STEM experiment outside to show you a little bit about rocket thrust. So I've got a rocket here. We're all kind of familiar with the engines, the pointy end on top, and a rocket taking off. And some of the take and make kits we've done have featured some stuff on rocket propulsion, like straw rockets, where you're providing the thrust kind of blowing a puff of air. And I wanted to talk a little bit about how that relates to the real science of a rocket on a combustion chamber. So a combustion chamber is the area above the engines where you're going to let those volatile chemicals kind of mix together to produce a reaction. So for most rockets, it's a liquid oxygen tank and a liquid hydrogen tank, and they'll be stacked on top of each other in the body of the rocket. And they're totally fine when they're in their own tank. Nothing's going to happen to them. But when you open those valves, when you hear that 10, 9, 8, they start to open the valves, and that's when they're releasing liquid oxygen, liquid hydrogen, and they're mixing together in that combustion chamber. And when they mix, you get that violent reaction. That's when you see all that steam or smoke come out of the bottom of the engine, the flame, and the rocket takes off the pad. So for our experiment, we're going to try to replicate that. Liquid oxygen and liquid hydrogen are hundreds of degrees below zero, so I can't use that, but I'm going to use something you may have in your house, like baking soda and some vinegar. So this is going to be my combustion tank. It's just an empty coffee can. See, no magic, nothing in there. But this is going to be our combustion chamber, and then when we put the cap on, that's going to be, if it was a real rocket, that'll be the rocket nozzle, where the exhaust will be coming out. So I'm going to set this up. I'm going to try to replicate keeping things separate on a tank. So we're going to say this is the liquid oxygen, which is the baking soda, and I'm going to pour that in the bottom of the tank. And as you can see, baking soda doesn't do anything if it's in a bag or in the can, so it'll be in the bottom there. And then to keep it separate until I want it to interact, I'm going to add the apple cider vinegar here, and I'm going to put that in a little Dixie cup. So I'll do about a half a cup. There's about 2 tablespoons of the baking soda and about a half a Dixie cup. And then if you can see, I'll get it closer there. I'm just gonna have it sitting like it's 2 separate tanks for our experiment. So they're not mixing, they're in the same element, same environment. And then if you wanna back up a little bit. So what I'm gonna do here is I'm gonna simulate that 10-9-1. I'm going to turn this over, which is going to have the cup tip, and so the vinegar and the baking soda will interact, and that interaction is going to provide a thrust vector for us, hopefully. So I'm going to turn this over, and then I'm going to run out of the shot. Ted, you can stay on this, and we'll see what happens, okay? Mm-hmm. So that pressure you see, and you can see the bubbles and the fizzing happening, but that's carbon dioxide gas that was produced, and it had nowhere to go. The gas kept building up and building up until it blew the lid off the top of the coffee can. So if you multiply that by 1,000,000, that's what you're getting when you have a real rocket thrust chamber happening, and all that violent reaction is happening. It's getting directed out the nozzle of the rocket. So I just want to share a little bit of Rocket 101 with you. Thanks for watching, and we'll see you again next time.